2-4, parallel and perpendicular lines. Parallel lines are lines that run alongside each other that they will never touch. Perpendicular lines are two lines that intersect and form a 90-degree angle. So writing an equation of a line parallel to a given line, what would be an equation of a line written in slope-intercept form that passes through the point 8, 9 and is parallel to the graph of y equals 3/4x minus 2. So parallel lines have the exact same slope. Parallel lines are lines in the same plane that never intersect. Non-vertical lines that are parallel have the exact same slope but different y-intercepts. So they start differently on the y-axis, but they have the same slope. So first, step 1, identify what the slope would be. This is correctly written in slope-intercept, so the slope of this equation is 3/4. So if the other line needs to run parallel, it needs to have the exact same slope. So the slope of my new equation would also have a 3/4. So using my same slope, 3/4, you could start with point slope form, which is y minus y1 equals m times x minus x1. This new line has to have the point at 8, 9. 8 is my x1, 9 is my x1. So y minus 9 equals 3/4 times x minus 8. Do my distributive property, 3/4 times x, 3/4 x, 3/4 times a negative 8. I can put that 8/1. 4 goes into itself once, into 8 twice. So 3 times a negative 2, negative 6. And then just to put it into slope-intercept, I can add 9, and my equation would be y equals 3/4x, negative 6 plus 9, positive 3. That is one way you can solve it. The other way is just to go straight and use slope-intercept. You know your slope is 3/4. They're giving you the point 8, 9, which would be your x and your y. So 9 equals your slope, 3/4, times your x, putting it 8/1, plus b. 4 goes into 8 once, into 8 twice, into 4 once. 3 times 2 is 6. Subtract 6 from 9. 3 equals b. So now you have your y-intercept. You know your slope is 3/4. So you end up with the same answer. It's whatever form you like to use and is easier for yourself. Now, let me see if I can fit that. Take this out, just so you guys can see why they would be parallel. The original equation starts at negative 2. It would go up 3 units, 4 units to the right. And now my new equation is starting at positive 3, also going up 3 units, 4 to the right. So these two lines would run alongside each other, parallel, starting at different y-intercepts, but exact same slope. You can pause and try these on your own. Always make sure that the equation that they are giving you is in slope-intercept in order for you to take out the slope. So letter A, y equals mx plus b. This just means that my b is a 0. If you were to graph that line, it would start at the origin, go down 2, 3 units to the right. So parallel, again, same slope. So the slope that I would have to use for letter A would be negative 2/3. The point that I would have to use would be 3, 5. Again, if you like to use point slope form, you can always start out here. Some students find this way easier. Y minus 5 equals a negative 2/3, but be careful when you are putting in a negative where you already have a negative. That would be a positive 3. Then you would need to distribute. Y minus 5 equals a negative 2/3 x, negative times positive, negative. 3 goes into itself once, a negative 2 times a positive 1, negative 2. Then all I would have to do is add 5 to the other side, and y equals a negative 2/3 x plus 3. If you want to see the other format, using slope-intercept, my y is my 5, slope, negative 2/3, times my x, negative 3/1, plus b, negative times negative would be positive. The 3's go to each other once, negative 2, negative 1, positive 2, subtract 2, b equals 3, and y equals your slope, negative 2/3 x, plus my y-intercept. So again, whichever way it's easier for you. Letter B, y equals 0x minus 3. So that means my slope is a 0, so my other equation also has to have a slope of 0. If we remember from the previous lesson, any equation that has a slope of 0, if you were to graph that line, it becomes a horizontal line. And again, just to give you guys a visual, if I were to graph this equation would be y equals a negative 3, because that would cancel out. So this would touch the y-axis only at negative 3. So in order for me to have another parallel line to this one, it would also need to be another horizontal line. So my new equation would just be y equals whatever the y coordinate is of the new equation my equation would be y equals the y coordinate of the ordered pair that they're giving you. So y equals 4. And again, if you want to check it, 1, 2, 3, 4. And this is touching 1, 4. So it's a horizontal line only touching the y-axis, going through the point 1, 4. Next would be perpendicular lines. So as you can see here, these are two examples. Line L is a red line. It has a slope of a negative 4/3. Line P, the blue line, has a positive slope of 3/4. One's negative, one's positive. All perpendicular lines form 90-degree angles. And if you were to multiply the two slopes, negative, they would always end up being a negative 1. So perpendicular lines are said to have the slope that are the negative reciprocal of each other. So here's the same concept. What would now be an equation of a line that passes through the point 1, 7 and is perpendicular? So now we are looking for the negative reciprocal slope. So step 1, use the slope of the given line to determine the slope of a line that is perpendicular. So the slope of my equation that they're giving me positive, and I'll do the reciprocal, which would be 4 over 1, which it would be 4. So here, again, they have you using point slope form. You don't have to use it if you like the other way better. So using the 0.17 and your new slope. So y minus 7 equals your new slope for x minus 1. Do your distributive property. Y minus 7 equals 4x minus 4, because 4 times negative 1 is negative 4. Add 7, y equals 4x plus 3. And again, I'm just going to go ahead and graph both of these so you can see what perpendicular looks like. My original equation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, starting at 0, 11, going down 1 unit, 4 units to the right. And my new equation, starting at positive 3, going up 4, 1 to the right. Perpendicular, these two lines should form a right angle, 90-degree angle. And again, if you were to multiply these two slopes, they should give you a negative 1. Alright, so here's your try it. Write an equation of a line that passes through 4, 5 and is perpendicular to the graph of y equals 2x minus 3. First step, identify the slope of the equation that they gave you. The slope here is 2. In order for me to write a perpendicular line, it has to be the opposite sign, so my new one has to be negative. And 2 is the same thing as 2 over 1. So if you do the reciprocal, it would be a 1/2. And now using the point 4, 5, using point slope form, y minus 5 equals a negative 1/2 x minus 4. Do your distributive property. Y minus 5 equals a negative 1/2 x. Negative times negative, positive, half of 4 is 2. Add 5 to both sides. My new equation is y equals negative 1/2 x plus 7. If you were to graph both of these equations, they would be perpendicular to each other. If anybody liked the other way better, using just slope intercept to find your b, 5 equals negative 1/2 times 4 over 1 plus b. Again, a negative times a positive, negative, half of 4 is 2. Add 2 to both sides. 7 equals b. So y equals a negative 1/2 x plus 7. It's pretty much preference in which one is easiest for you. Next here, they're going to give you 2 equations, and they're asking you, would these 2 lines, if you were to graph them, would they be parallel, perpendicular, or neither? First, you have to make sure that they are both written correctly in slope-intercept form, and then identify the slopes of both equations. Y equals, so the first one is not written correctly. So all I have to do to rearrange this to correctly write in the slope-intercept is divide by 3 into every single term. I cannot reduce negative 4/3, so that stays as a negative 4/3 x. 6 divided by 3, positive 2. This one is already in slope-intercept. Next, compare the slopes. The first one has a slope of a negative 4/3. The second one has a slope of a negative 3 over parallel, the two slopes would have to be identical, which they are not. In order for them to be perpendicular, they would have to be opposite sides and they're reciprocal of each other. They are reciprocal, but they're both negative, so they would not form 90-degree angles. So this one would be neither. We can do both A and B. You can pause, try these on your own. Again, always make sure that they're written in slope-intercept, which letter A both of them are. So letter A, comparing the two slopes. First one has a slope of 2. Second one has a slope of a 1/2. They are reciprocal, but they're not the negative reciprocal. They're not opposite sides. So letter A would be neither. Letter B, this one is a slope-intercept. I know this one already has a slope of -5. Standard form has to be rearranged to slope-intercept. So minus 25x, bring down the 5y, and x should go first. Divide by 5, and y equals a negative 5x plus a 1/5. This one has a slope of -5. -5 and -5, they are identical, so this would be parallel. Example 5, a landscaper plans to install 2 new paths in the park. The new fountain path will be perpendicular to the east path and lead to the fountain. The new picnic path would be parallel to the fountain path and pass through the picnic area. What would be the equations in point slope form? Y minus y1 equals n times x minus x1. That represents the new paths. Alright, so step 1, find the slope of the line that represents the east path. This starts here at 0, 2. There's another point here. So it goes up 1, 1, 2, 3, 4, 5. So the east path has a slope of 1 over 5. Or you could just use 2 over pairs, 0, 2, and 5, 3, and do slope formula. 3 minus 2, 5 minus 0, 1 over 5. So the slope of the line representing the east path is 1/5. East path, my slope is 1 over 5. So now find the equation for the fountain path. The new fountain path will be perpendicular to the east path. So the fountain now has the negative reciprocal. So the slope of the fountain would be a -5, opposite sign and reciprocal. And they're giving you a point here, so this would be 15, 2. So using point slope form, y minus y1 equals n times x minus x1. So y minus 2 equals -5 times x minus 15. Would be your equation in point slope form of the fountain path. Now find the equation of the picnic path. So east the slope